what I'm going to present is, on the one hand, our challenge, why we are doing what we are doing. Secondly, I give you an overview of the product and its features. Then we come to the backbone, why we are as good as we are. And last point is to summarize what we are currently working on in terms of modeling. So when we look at mankind's biggest challenge, we believe this is food production. As you might know, arable land is limited, and it's even decreasing due to climate change, soil erosion, soil degradation. So we estimate, or the Food and Agriculture Organization estimates, that we have to produce 70% more food by 2050. So how are we going to do this? I mean, when we look to the western parts of the world, Europe and the American, we have, in terms of production, really reached the limit. But when we look to other countries on the African continent or on the Asian continent, we figure out that there's a high potential to increase their yields. So what keeps these people back is mainly inappropriate access to knowledge, to profound agricultural knowledge, to good inputs like seeds, fertilizer, pesticides, but also to good machinery. So out there we have like 500 million smallholder farms or family farms that can really provide a big portion to get food security on a global scale. So PlantX is focusing, on the one hand, on the automated image recognition of crop damages. That means currently we are able to automatically detect over 400 plant diseases, pests, and nutrient deficiencies by sending a simple picture via smartphone. So that means our customers are on their field, they recognize a pattern which is not normal on their plant, and by taking a picture we provide an instant feedback of what is the course, what would be a preventive measure, how they can treat it, and what is a biological or a conventional solution. In addition to this, we also provide a library where you can manually search. This is very practical for users who don't have any Wi-Fi access at this very moment. Further, we have the PlantX community, where people from all over the world exchange on agricultural topics. And it's really lovely to see when people from Bangladesh helping or interacting with people from the American. So it's a great place to exchange about different issues. And our latest feature is the PlantX crop advisory. There we provide the farmer, based on his wish to cultivate conventional or biological. We provide information from seedbed preparation to harvesting stage. That means we accompany the farmers throughout the whole season, giving advisory based on his or her needs. Currently, we have more than 70% of our target group from India, but we have also a bigger audience in the MENA region, Northern Africa, as well as Bangladesh, Pakistan, Brazil. And we are currently trying to expand our services to Indonesia and Vietnam, so that we hopefully within the next 5 years reach from 1 million monthly active users to 40 million monthly active users. What is the key to reach to persons in remote areas, in emerging areas, in development countries? It's probably the content. You need to provide an easy, understandable content. Currently, the most agricultural content is written in a scientific way and in English. So this is not appropriate for our audience. That means we transfer the content into easy meanings, understandable meanings, and we provide at this very moment 18 languages. So covering from Hindi to Urdu to Russian, yeah, so that it's an easy entry point for our users to get familiar with PlantX. Here you can see our expansion from July 2017 to October 2018, and these dots you can see, these are only sent pictures. That means all other information we collect while people using our application are not displayed here. And as you can see, we were able within this time to really reach out to nearly every location in India, and these are the pictures from 1 month and not from the whole period. Due to our users, to the usage of the app, we have currently the biggest database in terms of crop damages worldwide. We have more than nowadays 13 million pictures in our database, which we partly use to set up new training sets, to enlarge our image recognition. And on the other side, of course, we test our image recognition with these pictures. That means we don't, of course, test pictures that we have used for the training itself. Wouldn't make sense. What is the advantage here? I mean, we really gather ground truth data. We really can see where do pests occur, where people grow tomato, where could be a food shortage due to weather or other events. Yeah? It's a highly diverse data stream. We are getting approximately between 20,000 and 30,000 data points a day, only in terms of images. So to get a better feeling how we are doing this, I mean, I already pointed out that the content and a meaningful translation of this is super important to attract people, to attract our target group. By doing so, we enlarge the data provided by our users. And this enables us to train models. Like, for example, come later to this. I will show you what we are currently working on. But that this is not only possible by bringing up an app, is displayed on this slide. I mean, we have a really difficult and very complicated infrastructure in terms of APIs and web apps working in the background. And here you can see for the content, we have several APIs and web apps, as well as for the community and also for the image recognition. And we produce all this in-house. So that means we need quite a lot of skilled people working for us. What kind of data are we able to process through our users? On the one hand, we know the type of farmer. Is it a conventional farmer using pesticides, or is it an organic farmer? We know what kind of machinery he is able to use. We know the location, we know the field sites, we know the crops he or she is growing. Every picture has a timestamp. We know, due to the crop advisory, the sowing date. We know the diseases that appear, and we also know the use of pesticides, the amount, and the use of fertilizers. So this is quite a huge bunch of information we are able to process in our models. And by doing so, by using our assets, we are really able to have the most diverse and accurate deep neural network concerning plant diseases on our globe. So here are some detection results. I mentioned we are using, on the one hand, pictures coming in from the audience from our users. On the one hand, we also make tests on the field. And for the majority, we reach an accuracy of over 90% out of the 450 classes we are training on. and which gives us an overall accuracy of 75%, which is quite impressive. What we are able to do, and this is some kind of information we, for example, provide to the state governments of India, is when we see that there is a severe disease spreading, as you can see here, August 2019, this is trips in Chile, and then within 1 month, it's really covering a much larger area than before. We are providing these kind of monitoring tools to governments so that people, stakeholders who are able to take action against such severe diseases are able to monitor and to decide, okay, what to do now. What we provide directly to our users are disease alerts. When we recognize that you, for example, as a potato farmer, are in an area of risk, we would send you a push notification. And last year, there was a new kind of disease spreading from Africa, initially come from the America to India. And we worked closely together with NGOs and the government to be aware of how fast this disease is called fall armyworm is spreading. And until within 1 year, we were able to send out over 500,000 notifications to our users to warn them that there's something dangerous around them popping up and how to protect their crops against it. And I mean, of course, the first step always is that you get real-time data through your users. The second step should be that you are not only helping them after a problem has occurred, but no, it should be that you are able to warn them even in advance before something severe has happened. And this is what we are currently doing with modeling. For example, based on weather information, we are estimating sowing and harvest date, and based on the information our users enter in the application, we see how this differ. Our recommendation in the dates and the actual sowing dates, and this is something we would like to intensify in the future, as well as providing information to agricultural-related industries or to governments to say, okay, there could be a food shortage in the near future, or there's an overproduction, for example, in groundnut. You can expect a very good harvest here. And the outlook is that we will continue doing so. We will predict the spread of plant diseases. We will inform our users when is the best time for sowing and irrigation. And of course, we will also increase the diseases and crops for our automated image recognition. And I close with our quote: we think software will eat the world, and hopefully PlantX will feed the world. Thank you.